For exactly 26 years, a single corporation held the undisputed title of South Korea's most valuable company, Samsung Electronics. They weathered global financial crises. They dominated the transition to smartphones. They seemed entirely untouchable. Until today.
On June 22, 2026, the unthinkable happened. SK Hynix reached a market capitalization of 2.08 quadrillion won. That's roughly 1.36 trillion US dollars. In a quiet but absolutely seismic shift, they unseated Samsung. And this wasn't just some market fluke. It was the exposure of a massive realignment in the global tech hierarchy, driven entirely by the artificial intelligence boom.
Welcome back to Learning with Pratik. If you're new here, I try to increase neuroplasticity by exploring a new topic every day. I do all the reading and researching so you don't have to. Today, we're unpacking exactly how a highly specialized structural shift in technology allowed a laser-focused memory maker to dethrone an absolute empire.
We'll be breaking this down into 5 distinct chapters. 1. The fall of a giant. 2. The AI memory bottleneck. 3. A near-death revival. 4. The NVIDIA Alliance. And finally, Chapter 5, the 29 billion bet.
Chapter 1. The Fall of a Giant. You see, Samsung's displacement wasn't an accident. It was the direct result of a fundamental change in what the tech industry actually values right now. Scale in conventional hardware, it's just no longer the ultimate prize. Just consider the sheer scale of the financial pivot in SK Hynix's first quarter numbers for 2026. Revenue hit an astonishing 52.57 trillion won. But the truly staggering figure here is the operating profit, 37.61 trillion won. That translates to an unprecedented 72% operating margin. To put that into perspective for a second, imagine building a highly complex physical piece of hardware, and you get to keep 72 cents of every single dollar as pure profit. In the historically brutal, low-margin memory market, a 72% margin is a statistical anomaly. It's a number driven almost entirely by insatiable, structural AI demand. The world suddenly needed a very specific type of hardware, and only one company was truly ready to supply it at scale.
Chapter 2. The AI memory bottleneck.
To really understand those margins, we have to look at the physical limitations of artificial intelligence hardware. Enter high bandwidth memory, or HBM. Think of a standard computer chip like a brilliant professor, but one who can only read a single book at a time. HBM changes the game entirely by stacking DRAM chips vertically. It's essentially a skyscraper of data, and connecting them with thousands of microscopic through-silicon vias. These vias are basically microscopic elevators punching straight through the silicon, allowing massive volumes of data to travel up and down simultaneously. Without this highly specialized memory sitting directly next to the processor, NVIDIA's ultra-powerful H100 and H200 GPUs basically just sit idle, waiting for data to process. They're starved. The entire multi-trillion-dollar AI accelerator story completely falls apart without it.
And this dynamic brilliantly illustrates who actually controls the bottleneck of the AI revolution. In the first quarter of 2026, SK Hynix commanded a dominant 58% share of the global HBM market. That left Samsung and Micron tied at just 21% each. Samsung, despite its virtually unlimited resources, is fighting from behind. They've faced repeated qualification hurdles. Because, as you can imagine, stacking chips vertically generates massive amounts of trapped heat. Samsung struggled with thermal performance issues when trying to cool NVIDIA's most demanding chips. In the AI cycle, the scarce part gets the pricing power, and SK Hynix figured out how to keep the skyscraper of data from burning down.
The crucial realization here is the stark difference between old memory and new memory. Conventional DRAM has a brutal, almost miserable history. It's a never-ending roller coaster of boom and bust pricing cycles, chronic oversupply, and pure commodity status, where chips are literally sold for pennies. AI HBM, though, it's an entirely different beast. It's characterized by structural scarcity and rigorous, highly customized client qualification. It's not a generic side product, it is core AI infrastructure. Customers are so absolutely terrified of missing the AI wave that they're reserving SK Hynix's supply years in advance. They're doing this just to ensure their billion-dollar data centers don't turn into very expensive paperweights.
Chapter 3. A near-death revival.
What makes this rise to absolute dominance so compelling is that the current king of South Korean tech almost ceased to exist entirely. Let's trace this dramatic arc for a moment. Back in 2002, the company, then known as Hynix Semiconductor, was drowning. Crushed by billions in debt and a total collapse in global memory prices, they were nearly sold off for scraps to their rival, Micron. In a desperate final move, the board and the labor union narrowly rejected the buyout, opting to try and survive on their own terms. It took a decade of grinding recovery until SK Group finally stepped in during 2012, acquiring a major stake and stabilizing the ship. And because they couldn't outspend Samsung in standard memory, they made early, intensely focused bets on highly experimental tech like HBM. By 2025, that desperate bet paid off, securing them the majority market share. And by 2026, the very company that Micron once tried to swallow whole had officially overtaken Samsung to become the most valuable publicly traded company in South Korea.
Chapter 4. The NVIDIA Alliance.
Now, SK Hynix isn't just riding a temporary market anomaly here. They are actively building a strategic moat to ensure this dominance is permanent. Listen to this sentiment from June 2026. NVIDIA CEO Jensen Huang stated, "AI factories are the engines of the next industrial revolution, and advanced memory is essential to their performance." This wasn't just standard executive praise thrown out casually at a press conference. It was the formal acknowledgement of a deep, multi-year technology partnership designed to lock in the absolute future of global AI infrastructure.
This alliance goes way beyond basic transactional supply contracts. SK Hynix and NVIDIA are deeply co-engineering the future. They're already co-developing memory specifically optimized for NVIDIA's upcoming Vera Ribbon AI supercomputers. But it actually goes both ways. SK Hynix is now applying NVIDIA's CUDA-Hex libraries to accelerate their own complex semiconductor physics simulations. They're even building 3D digital twins of their fabrication plants using NVIDIA Omniverse. Why does this matter to us? Because they're paving the way for fully autonomous AI-driven manufacturing. Artificial intelligence is literally helping build the highly specialized factories that will in turn build the next generation of artificial intelligence. It's a perfect loop.
Crucially, they're cementing this infrastructure directly into the American supply chain. They are currently establishing a massive $4 billion, 133-acre advanced packaging facility in West Lafayette, Indiana. Furthermore, in March 2026, they finalized the governance restructuring of their U.S. subsidiary, SolidDim, consolidating its operations into a unified AI company vehicle. This isn't just about logistics, folks. It's about geopolitical security. It allows them to deliver full-stack, made-in-America capabilities to their biggest tech clients, capturing the impending era of agentic AI right where the demand and the capital is highest.
Chapter 5. The $29 billion bet.
To solidify this permanent lead, SK Hynix is turning to the global financial markets. $29.4 billion. That is the targeted size of SK Hynix's planned July 10th NASDAQ ADR listing. An ADR, or American Depository Receipt, essentially allows U.S. investors to easily buy shares of a foreign company. If successful, this listing would completely eclipse Alibaba's 2014 record as the largest ever. This is a staggering capital raise. It's a deliberate, highly calculated move designed to break free from the traditional valuation limits of the Seoul exchange. They want to capture the massive, near-mythical AI premium that U.S. investors are currently willing to pay for foundational companies like NVIDIA and TSMC.
Let's look at how this capital actually builds their ultimate advantage. They aren't raising almost $30 billion just to tell a better story to Wall Street. They're raising it because the memory shortages we talked about are structural and physical. They need the capital to fund next-generation fabrication capacity and to finance an incredible 11.9 trillion won order for extreme ultraviolet or EUV lithography equipment from ASML. Now, EUV machines are essentially the most complex optical instruments in human history, strictly required to print the impossibly small circuits of modern chips. By breaking the historical memory stock discount, they're forcing the market to price them not as a cyclical commodity chip maker, but as a permanent, absolutely indispensable pillar of AI infrastructure.
Which brings us to a rather critical realization. As memory becomes the absolute bottleneck of this next industrial revolution, who truly holds the long-term power in the AI supply chain? Is it the brilliant architects designing the chips, or is it the physical foundries uniquely capable of feeding them the data they need to survive? I'd love to hear your thoughts on this in the comments below. Thanks for watching. Tomorrow we open a different page. Until then, Pratik out.